Hello, everyone. Welcome to today's session. We're so happy that you could join us for the webinar today. Before we begin the session, I do have a couple of housekeeping announcements, things I'd like to share. We have an upcoming webinar on Wednesday, December 4th, Collaborative Care in Motion, the Power of Nursing and Ergonomics in Workplace Health. So you can be sure to check that out at coeh@berkeley.edu/webinars. And on behalf of education and research centers throughout the country, it's my pleasure to present our industrial hygiene webinar series. This is a collaborative effort on behalf of each education and research center's continuing education program, and our goal is to provide you with access to current research supported through NIOSH ERC programs. We really appreciate you being here today. Today's webinar, Current International Research Efforts for Traditional Occupational Aerosol Samplers, is presented by Darrah Sleeth, PhD, MPH, and the Rocky Mountain Center for Occupational and Environmental Health. You are going to be muted during this presentation, so if you'd like to ask a question, please enter it into the Q&A. We'll be saving time at the end of the presentation to address as many questions as possible. We're also going to have the chat open, so feel free to participate and join in the conversation, say hello to one another. And please put the questions in the Q&A. That'll help me at the end, make sure we can address all of those questions and they don't get lost in the chat. The presentation is being recorded and will be made available on the Center for Occupational and Environmental Health YouTube page within 5 business days. And all participants who logged in today for the full live presentation will receive an email tomorrow with a link to our evaluation form that will qualify you for a certificate of completion with 1 continuing education contact hour. Once the evaluation is completed, you'll be able to access and print your certificate. And without further ado, it's my pleasure to welcome our speaker for today. Thank you so much for being here, Dr. Darrah Sleeth. Dr. Sleeth, PhD, MPH, and CIH, is a professor in the Division of Occupational and Environmental Health and the affiliated Rocky Mountain Center for Occupational and Environmental Health at the University of Utah. She has been at the University of Utah since 2010 and currently serves as the Industrial Hygiene Program Director. She earned her PhD in Industrial Health and an MPH in Industrial Hygiene and Hazardous Substances from the University of Michigan, as well as her BA in Integrative Biology from the University of California, Berkeley. She is also qualified as a certified industrial hygienist. Her research interests include exposure assessment for airborne respiratory hazards, particle size selective sampling methods, and indoor air quality. We're looking forward to your presentation today. Thank you so much for being here.
Great. Thank you so much, Michelle. And thank you everybody for joining online. Today, I'm going to talk about aerosol samplers, something that's been near and dear to my heart for over 15 years. And we're going to talk about some international research efforts in this area. There's a lot going on. We're trying to come together, put together a lot of information that's out there. And I'm going to talk about what our group's doing and then some stuff that I'm doing and some of our kind of hopefully future work. All right, so I want to start with some of our kind of acknowledgments of the people who are involved in this. So we put together this International Sampler Comparison Group, or the ISCG, we call ourselves, several years ago. And it was really a coming together of people interested in aerosol samplers. We're sampler nerds. We want to talk about this as much as possible. So we've got this great core group of Dr. Martin Harper, Peter Abartier from the Belgian Occupational Health Center, Marcus Catani from Edith Cowan University in Australia. And really, it was a child of Stephen Verpile in Belgium, who's associated with the Nickel Institute and also the Belgian Center. And our group is really well managed by the Institute of Occupational Medicine in Scotland by Karen Galea, who also has a lot of exposure science background. This is our core group of folks that have done a lot of work here. And we've got affiliate members, so we want to talk to other people who are experts in this area. So we talk to folks at NIOSH, at the UK Health and Safety Executive, at the IRSST, the INRS, IFA, all the all the different institutes that are interested in occupational health. We really try and get them involved in some of this conversation too. Currently, we've been sponsored by a bunch of medical associations, and so they've been instrumental in some of what we can do. And so it's something that we're trying to build a consortium around this topic. And you'll see later we have annual reports, and you can look at all of our activities. So really what I want to talk about is our current projects. And these are kind of the five main things. My goal is about laboratory studies and some related field studies. And so I'll talk about in detail in a minute. But really, it's really aerosol sampler performance. So a lot of people who are listening are going to be using these typical aerosol samplers, cyclones, cassettes, and really somebody at some point should have tested them in a lab. And so what I'm interested in is how was that done? Was it done in an appropriate way? Some other projects include validation of specific samplers. So Stephen's looking at a multi-fraction sampler specifically for metals in workplace air. Marcus is looking at field data. So in Western Australia, they've put a whole bunch of samplers in different mines and looking at, can we compare them in the field and what does that look like? And then two more projects I'm going to talk a little bit about at the end. Martin Harper's project on consensus recommendations for aerosol sampler selection. So this is combining decades and decades of information on sampler performance. And then kind of coming off of that is Peter's tool for sampler selection. So we've all been having these really interesting discussions about how would we tell people what sampler is best. And that's, I think, really the goal for a lot of what we're doing and what the ISCG is interested in is how can we standardize sampler selection? If you look at and I'll talk about this in a second too, but there's so many options out there for samplers that you can choose. And so we really want to make sure that people have the right information to make that right choice, to keep workers healthy and safe, to make sure they're not wasting resources. There's lots of reasons for continuing with this. And so that's really the main problem here is there are a lot of samplers to choose from. So there was a study done in the nickel industry, and they found dozens and dozens of different samplers were being used to effectively measure the same thing. And so the idea that why can't we just choose one that's best, or maybe a couple options, why do we have to have so many different options? And with so many options, how many of them had really good data to say, yes, this is going to sample what you think it's going to sample? So there's a lot of samplers to choose from, and really we want to know what's the best. And really the standardization of how we test them has been limited. And so this was some of the early work that I did was looking at sampler performance studies. And so we did it one way that we thought was best, and other labs would do it a different way. And we have to try and figure out which, are they both good? Is one better than the other? Can we come up with some idealized way of testing these samplers? And so in Europe, they did actually put together a sampler performance standard. So this is a EN standard for assessment of sampler performance for measurement of airborne particulate concentrations. And so this is used in Europe, but really it's not an international standard. We really want an ISO equivalent that folks from the US, from Canada, from Asia have had input on. And interestingly, this standard's been out there for many years, but there's not really validation data to show that yes, it is the best. It is working the way we want. It is giving us the best sampler data. And so that's why we want to work towards an ISO equivalent and get this sampler performance to be optimized. And then another big issue, because I mentioned field studies, some of what we're doing is in the field, is really what's the relationship between those laboratory studies and the field data that you're going to collect, right? I mean, that's the ultimate goal, is to get good field data. And so if we're testing them in a lab in a way that's not relevant for the field, then that's going to potentially cause inaccurate decisions to be made. You're not going to be able to rely on your data. And so we really want to make sure that there's a really clear connection between laboratory studies of samplers and that field data that they're ultimately collected with. So what does it look like in the lab? Many people may never never know what happens in the lab to test these samplers. But there's been many, many studies conducted over, decades. A lot of times we'll use a wind tunnel, which is going to be something which has unidirectional airflow that's really well characterized, and we can control it really well. And that's for environments that have some air movement. But then we also might want to conduct them in calm air chambers. So we have some of those studies that were done because indoor environments, if you think of offices, but also potentially really manufacturing locations that don't have a lot of air movement, we have some indoor environments that have relatively low airspeed. And so we kind of want to conduct our experiments in something like that. Um, some of the differences that you might see in the different methods also involve the reference samplers. So we might look at optical particle counters. We didn't really have that technology maybe 40 years ago when we were doing that wasn't as good as it is now. But you might see different types of optical counters, and is one better than the other? Are they going to give you the same data? We still don't actually know that. And then for some samplers that we test, we have to use isokinetic reference sampler. So in this case, we can't really use that real-time technology. We have to do something a little bit more, and we have to do a gravimetric analysis. And so there's a very different setup there. And so again, are those samplers going to give you the same results if you're tested that same way? Another difference you might see in these laboratory protocols are the types of particles. And this is another really important one when we want to connect the laboratory to the field, is what you're testing them with. Is that relevant for field data? So when we look at especially inhalable aerosol samplers, we'll see that aluminum oxide is used a lot because you can get very monodispersed, so very narrowly sized particles. But sometimes we might want to use polydisperse, so particles that have a lot of different sizes, especially for respirable samplers, we might use those polydispersed dust. But what is it made of? Is it a test dust? Is it Arizona road dust, where they effectively just take dirt from the side of the road and that's what we're testing it on? Or is it glass microspheres, something that's a little bit more manufactured for this? So again, that's an important issue we haven't quite settled. When we look at these methods, you'll also see typically co-located samplers. You're gonna test, maybe 3 to 10 of them at once. And if we're not using a optical particle counter, we're probably going to do gravimetric analysis on site. And so that's going to be something that is, again, if you're interested in silica, you're going to want to do silica analysis. If you're interested in metals, you're going to do some other analysis. So is that gravimetric analysis still relevant when we go to the field and do something different? So we really want to optimize what we're doing in the lab and to match some of those issues. So this is what a typical, and before I move any further, I want to talk about what these sampler performances studies might actually look like. So for an inhalable sampler, so like an IOM or a button sampler, this is what it looks like. We have an exposure chamber, we have a mannequin. So in this case, we're going to have this one has different samplers, but you might have like 4 of the same sampler on it, and it's going to rotate. It's going to, simulate a worker moving. It might not, workers don't stand there walking around in a circle, but it gives you some orientation averaging as opposed to just unidirectional flow. So we're going to pretend like it's moving. In this case, the picture of the sampler here is our isokinetic reference sampler. And so if you, I don't know, go back to Industrial Hygiene 101, that isokinetic sampler is one where the air velocity inside the sampler matches the air velocity in the environment. And so you're not going to over under sample. You're going to have really a true concentration sample. In this case, we have monodispersed dust because it's inhalable, so that range up to 100 microns, we're going to have to get a bunch of different sizes, and we really want to look at them individually. The sampling time is usually about 45 minutes because we usually put relatively higher concentrations in here, but is that going to be relevant for the field? Usually when we're in the field, we're going to be measuring for 4 to 8 hours, right? So that's one thing we haven't quite answered is that lower sampling time going to give you the same results for a sampler performance study? And then for these, we do a gravimetric analysis. And this is what our data might look like. So we're going to calculate the sampling efficiency. And what that means is that we have that sampler concentration that we measured from the sampler itself. And we're going to compare that to the isokinetic sampler concentration, and we get this ratio. And if it's 1, if that value is 1, that means that the sampler was measuring the same as what's in the environment. So that would be 100% efficient. But in reality, we don't really want our samplers to do that, because if it's an inhalable sampler, we know that there are some particles that we're not going to inhale, so we don't want to measure. And so this is where our sampler performance studies can show us, is it going to be, are we going to be over or under sampling compared to this inhalable convention, which is that line in this figure here. So we generate an efficiency curve, and we compare our data to that inhalable curve. And you can see in this example from this study, there was a bunch of oversampling, and that was mostly because it was in really low wind speed. When we increase the wind speed, then we actually lower that inhalability. But this is what the data analysis might look like. So there's some samplers that we're interested in and that there's actually quite a lot of data on. So we have the IOM sampler, one with the conductive plastic and one with the stainless steel cassette. We have the closed face cassette. This is, you think of as a typical OSHA total dust sampler. So it's not technically an inhalable sampler, but we kind of treat it and put it in this category for testing. And then we have the disposable inhalable sampler, which is shaped like the IOM, but is made out of cheaper material, so it's going to be disposable. So these are some of the ones we're interested in. Next, I want to talk about what a typical respirable sampler performance might look like. And you'll see this is going to be very different in some respects and similar in other respects. So if you're using a cyclone or a PPI or some other sampler that's measuring the respirable fraction, hopefully it's been tested in this way. So in this case, we'll have some exposure chamber, and it may or may not be a wind tunnel. It might just be a calm air chamber. But in this case, we're going to use a real-time particle sizing instrument. So something like the TSI aerodynamic particle sizer or a GRIM spectrometer. And effectively, this will give us, for very small ranges of sizes, it will give us concentration data. So we can get a really nice size distribution, and we can look at the concentration over all those sizes at one time. It's very hard to do that with large particles, so we can't really do that with our inhalable samples. So what happens is you have this instrument, and you have 2 lines, one line that goes to a reference, which is an open tube, and one that goes to your test sampler, something that has no filter. So it's going to be analyzed by the instrument. And so we're going to effectively alternate sampling between these 2 lines. And that's what we're going to then use to measure or calculate the efficiency. So in this case, it's only 1 minute per sample. So even though, we thought 45 minutes, maybe that sounds low. Well, this is a 1 minute sample, so they're even smaller. So again, how does that relate to a larger sample size or larger sample time? In this case, we also typically use polydispersed aerosols, because in this case, the instrument is going to size those particles after they're sampled. Whereas with the inhalable studies, we've effectively sized them before we use them because they're monodispersed. So that's really the difference with the type of aerosols we use. But keep in mind with the type of aerosols we use here, because it's a real-time instrument, it's going to use some sort of laser. The refractive index is going to be important. The type of particle might be important. The way it's reflecting the light in that instrument. And so again, something that we're still interested in really fleshing out. So the respirable samplers of interest, some of you have probably used these. So the Higgins dual cyclone or the aluminum cyclone, there's a lot of new interest in the PPI. So instead of using a cyclone, it uses impaction for sampling. And you can also get the disposable inhalable sampler that has a foam insert, which then would also sample the respirable fraction. And so that's also a relatively newer innovation for that traditional aerosol sampling. So these are ones that we're interested in, that we've been putting in a lot of our studies. So the data analysis for these samplers looks something like this. So again, we're calculating a sampling efficiency, and then we're going to look at that ratio of the concentration through the sampler compared to that reference. So in this case, through those two different tubes that go to that real-time instrument. So you get a lot more data points along this line. Um, so you have each size bin can have their own concentration data. So you get a lot more data. And we can generate an efficiency curve, and then we compare that to the respirable curve. And we can also create what we call a bias map, where we understand how far from that reference line is our sampler performing. And so those are some of the data that you might see when you look at the literature. So these bias maps and these curve generations. And so this is what the bias map might look like. It's um, it's something you don't see all that often, I guess, in industrial hygiene and data analysis, but for respirable samplers, this is kind of the gold standard of what we look at. So we're going to compare how well our sampler is performing to an idealized set of dust. So we pretend like we're throwing dust at it, and we say, what would be the bias from that sampler to the respirable curve? So the example shown here, if you have some dust that's 10, the median diameter is 10 microns, and it's got, a GSD, so it's relatively narrow to a GSD of 2, you're going to expect about 20% bias from that sampler to the respirable function. So effectively a 20% overestimate. And so this is kind of a unique way of analyzing those for our cyclones in particular. All right, so with that background of what kind of sampler performance tests look like, then I wanted to share some of our kind of results we've come up with recently about comparing these. So we've done a lot of comparisons between labs, within labs, looking at what's going to be the best type of test. So one thing we found was that different labs consistently resulted in different respirable sampler cut points. So that D50, you're trying to get for respirable cyclone or respirable sampler, a D50 of 4. We often see different results, and with that comes different bias maps. And so what is that? Why is that? What is it about these tests that are causing these differences? One thing that we're kind of honing in on is this reference sampler, because that's really critical for measuring or for generating a curve and for calculating sampler efficiency. And so the reference samplers, are they equivalent if you're using different optical particle counters? What is it that is maybe caused this sort of unstandardized method to cause different results? And as I just mentioned, we have different test methods for inhalable and respirable samplers. And so one concern is, what does that mean for our data, especially if you have a sampler like is this dual fraction samplers? What does it mean for those results if we want to implement a dual fraction sampler, but they have two different tests that are required to test them? And maybe some nuances there that we have to figure it out. One thing we did see within a given experiment, that actually side-by-side samplers in these tests had very low coefficient of variation. So that was very nice to see. I don't want to be all doom and gloom about this. So we've got, less than like 10, 11%. We've got lower CVs in that when we looked at all these types of samplers I've been mentioning. So the respirable, inhalable, and that closed-faced cassette sampler, we had pretty good agreement side by side. And so that's really, really a nice result. So a lot of this, it also tells us that a lot of these differences between labs isn't necessarily within experiment variability, but it's probably intra-experiment variability. So with all that, we have some issues we want to keep studying. And so we've got some plans for this, and some of it is ongoing. So that reference instrument standardization, we're currently testing this in my lab right now. We're looking at different types of reference instruments to see if we can side by side, if they can give us similar results, and what that, and if they not, then why. We're going to also look at different particles. So we've got aluminum oxide, we've got the isotest dust, different types of things that, again, we don't really know the importance of that when especially when we're looking at um, optical particle counters, where that material that you're testing actually can interact differently with that instrument. One thing I haven't mentioned is the concentration used in the chamber, and that kind of goes along with sampling time. But when we have really high concentrations over a short period of time, is that going to be a good method versus, a more reasonable concentration over a longer period of time, which is more what you would see in in the field. So that sampling time, and you've seen 1 minute, I've even seen 30-second samples. It's really hard to do 8-hour samples in a lab, but it might be necessary to test that. So that's something we're going to be looking at. And performance changes for loaded versus unloaded samplers. So this is again something that has come up, especially when we've looked at a lot of published literature and some of our own data, that loading versus unloading, is that going to affect the results of a performance test? And that again goes to the concentration and sampling times. Those are all kind of tied together. An interesting one so here in Utah, we're at about 5,000 feet. And so there's been a question of whether air pressure differences affect the internal separation of a cyclone. So regardless of the pump, the pumps can address some of these air pressure differences, but that cyclone has been designed a certain way. So that's something that we're trying to design maybe a test to look at, is air pressure difference. So we're up here at altitude. Would our results be different than if we went down to sea level? And then going even further, if you went down in like a deep mine, you're going to have even different pressure again. So what is that important? And hopefully not. I mean, that would be the ideal outcome of that, but we haven't tested it. So there's been some guesses about whether that might be an issue and ways we might deal with it. So stay tuned for that one. And then finally, the type of chamber. So I mentioned we often use a wind tunnel, but sometimes labs use column air chambers, and they effectively expose these samplers in a different way. And so we kind of need to understand, is one better than the other, or are they both okay? And so another thing I wanted to talk about, which I think is really, again, critical for keeping what I do in sort of a practical light, is lab to field issues. And so one thing, and this little video here is from Marcus in Australia. This sampler here, this is what they call the WAM, the Workplace Atmosphere Monitor. And you can see it, they put samplers on the outside of it to do some area sampling in a mine, right? Places where maybe we can't get to with people, or we want to kind of test these samplers next to each other in that field environment. And this has been used, and we have one here we've used in mines in the US. There's one in Europe that's also being used. So that's kind of one small way we're trying to look at the lab to field issue. So we're testing that in our lab as well to see if that variability is low enough. But really, one of the important questions is that instrument performing the same in the lab as it does in the field? And so that's still something that even after these many decades, we still don't have a great answer on, because we don't really have the tests for it. And so we're trying to understand what that might look like. And one way we test these, right, is with that optical particle counter as a reference. In that case, we're not actually using the cyclone, in particular a cyclone, in the way that it's used in the field, right? You're removing that filter, you're removing that additional analysis, and so there's still a question about how we tie those together, and maybe it's good enough. We just need to kind of fully answer that question, and that also kind of goes to analytical techniques. So you have that optical particle counting, and gravimetric, but then you also have that further chemical analysis, where is that performance going to be the same? And I think the assumption is yes. We just want to make sure we can test that and be confident in that. And then I mentioned the concentration and sampling time already, but what we use in the lab, we really want it to be relevant for the field. And so we want to make sure that whatever standardized tests we suggest are going to be valid for that comparison. Oh, yeah, there's that. All right, so what are our next steps? Well, as I just showed you, we've identified issues that might require testing, and now we're prioritizing them. So we're in that realm right now. So I think that reference sampler is really important, and the particle type. So we've kind of prioritizing some of these, and then we're doing some experiments, and then we need to really optimize those protocols. So optimizing the laboratory testing of these, but also the field testing protocols. So if you've ever read the SEN standard I mentioned, they do have field testing protocols, and so that's something that it's very we think it's really great that those were added. We just want to make sure that those are also optimized and we don't lose sight of that field testing piece that it can be really important for understanding how the sampler is performing. So all of this work is really going to provide validation for these standards. And also, as I said, developing an ISO standard, something that people can really kind of hold on to as like, this is how it should be tested. Is a manufacturer, do they have that data? Can they tell you that, yes, it meets that standard? That would be, in our view, an ideal sort of sampler outcome, is that we have an ISO standard that people use and can trust that that's going to give you good data. So other progress and some other things I wanted to talk about. So we have currently a commentary paper. So it started out smaller and is now very big, but it is more of a commentary on sampler performance studies. And so this is under review at a journal. And basically, we've looked at all those sampler data that's been published, so you don't have to. If you're using one type of sampler, you don't have to go and find all that data. We've compiled it, so it'll be hopefully a very nice reference in terms of you want to use a respirable sampler. Well, here are all the issues with these samplers. Here is all the good things about these samplers. We're going to really have a nice resource for that. And then from that, we want to make something a little bit more accessible than an academic paper. And that's where the sampler selection tool is being developed. And so I'm really excited about this. So this is going to be taking all that information from both laboratory studies and field studies, what people think are, what are the important parameters, and put it into some sort of tool, some sort of app that you can put in your scenario and say, I am going to be measuring, I need to measure silica at this mine. I want to use this, I have these other considerations. It'll tell you, okay, maybe you should consider this sampler or this sampler, and these are the pluses and minuses of both of them. So I'll show you some example in a minute, but we're really excited about that. And then finally, as I mentioned, collaborating on this ISO standard. So from the commentary, so this is something that's been a labor of love, I guess you could call it, of getting all this data together, and have some conclusions and some recommendations that I'll go over for people who actually use these. So I want you to take away from this talk, not just understanding of what a sampler performance test looks like, but some things that we have found over the last 40 years of this. Well, unfortunately, one of the things we identified, some samplers have very poor performance, or they have other defects that suggest they need to be avoided. And so examples of that might be samplers that consistently underperform relative to their criteria, or they have the material might have defects, so it's not conductive plastic. There's other defects that are suggested to be avoided. It also came to not surprising that many samplers only have very limited validation, and so that needs improvement if they're going to continue to be used. And so we have outlined in the commentary where that data is really robust, where there's a lot of data, and then also where maybe there's one or two studies, maybe there's not very much, not any published literature on it, and just so that you're aware of what's out there. There is no perfect sampler that can be used in every situation. That's very clear. Every sampler has some disadvantage. So if you're really, you love your sampler and you're not going to change, just know that there's going to be some disadvantage of it, but just unknowing that it is what that is, and if you can live with that, then um, that's kind of what we want to give you, that knowledge to make that choice. Um, some samplers have advantages in some respects and disadvantages in others. And so, how do you choose it? Again, it goes to your situation. Are you comfortable with high transport losses because you're not transporting it very far versus, you know, you want something that you is really, really reliable and has a lot of data behind it. You can make that choice based on your situation. But really, the question is, which of the aspects are most important? What can you tolerate? And so, just giving you that knowledge is going to be part of what we're trying to do. So, the recommendations from the commentary. One thing that kind of showed up consistently is that wall deposits are important and can't really be corrected for. And so this must be accounted for in the analysis. So there's some methods for this, but really it needs to be really explicit. So there's a lot of sampling and analytical methods that could be improved in this respect. It is the um, guideline or policy of OSHA that they include those wall deposits in their samples. So if you're not doing that in your samples, you probably should be. And there are ways to do it. We have those inserts you can use, which is probably the easiest way to deal with it. But also, there are methods for wiping or rinsing or using, yeah, again, fully digestible type samplers. With cyclone samplers, the recommendation is to always use conductive cassettes. And that kind of goes to that first point, is that they are not going to have as many wall deposits. And that's can be very important, especially for certain types of dust. But really, as conductive cassettes should always be used. So that's one recommendation. And excuse me, in many situations, we have much lower limit values, and we need higher sensitivity. We have, in our analytical methods, we have to have larger sample volumes. And so that's going to require potentially larger samplers, but also potentially heavier pumps. And so keeping that in mind of what type of sampler you want to use, can it handle that larger pump? Can it handle larger sample volumes with this, eye to the future of potentially lowered limit values? And then, as a lot of things in industrial hygiene, it's really going to depend on your situation. So there's no perfect sampler, but some are better than others. And where that's true, we've trying to highlight that. And how do we tell? Well, one thing we're working on next with the sampler selection tool is also kind of bringing experts together to try to identify what are the most important factors. And so again, if anybody is listening is interested in being involved in those, please reach out. We love especially practical feedback on this sampler is really hard to use in the field. This one's not. So that's also information we're going to be using for this commentary, is the usability of it. So there's some things that, if it's just there's one sampler it has a internal pump, that CIP10. I don't know if anybody's ever used that. It's got sort of an internal pump, and there's a very unique way of setting the flow rate on that, or checking the flow rate on that pump. And most people don't want to do that whole different thing. And so that kind of pushes it down a little bit in that hierarchy, just because it's a little bit harder to use and implement in practice. So that's all information that we definitely are interested in as well. Oh, one note that I wanted to make. So when it came up, and I've been using these samplers for a long time. I didn't actually know some of this until we started looking into it. But the Darrah Oliver cyclone is actually probably the most well-studied industrial hygiene sampler out there, because it is used in coal mines as part of that coal mine personal dust sampler. And so because it's used as that, and that's sort of a well-regulated thing. Every time it changes, everything, every detail of it is actually under the control of NIOSH for based on some federal regulations. And so everything has to be approved. Any changes have to be approved, you know, potentially involving testing before it can be used. And so I found that fascinating that there is one sampler like that. But there's a lot of people who don't use this or wouldn't use it. But definitely it's something to consider. Do we want other samplers like that? You know, if people have a preferred sampler, you know, would that be a good thing for your sampler? Would you like to see more of that kind of regulation behind what we're using? Maybe, maybe not. All right, and then next I want to talk about the sampler selection tool because, like I said, all this lab work, all this literature review, I think is going to be a really neat outcome of this. So the objective is to develop an app-based tool based on this database of all this information and some, expert guidance from folks, not just our team, but around, all these affiliates from what they know about samplers and have seen with samplers. So it's going to be based on this literature, this validation literature, from people criteria that, people suggest, and we can talk about and discuss which ones are going to be the most important. So some examples are the uncertainty of a sampler, um, the coefficient of variation of co-located samplers, those bias map data, is that important? Transport losses, like I mentioned, where does that fall in that hierarchy of performance criteria? Things like wall deposits, that ease of use, in some cases that might pop up and be pretty important. And then other kind of nuanced things like wind speed, orientation, which criteria are going to be the most important. And so that's one thing that we're going to kind of convene some experts to get information on, can we kind of agree on what's most important. So we're also going to use criteria from these lab studies and also workplace studies that I mentioned that are ongoing. And then evaluation per type of particulate matter in workplace. So effectively, we want to be able to say, okay, what type of dust are you sampling? Where are you located? What does that workplace look like? And give you information specific to that. And so we want to be specific enough to be helpful for folks who are actually in the field using this. So I'm very excited about some of that. And this is what it might look like. Again, this is the like Word document version of what that looks like. But so that it's going to have some sort of input of, and I'm looking at respirable silica in a mineral processing plant. The person is the miller operator. We know what the wind speed is. It's pretty low. We expect the dust concentrations to be, maybe relatively low for for um, for occupational settings. It's an 8-hour shift. This is the kind of analysis we're doing. What kind of sampler would you recommend? And so the output would be not just, okay, use this, but here are the options, and this is sort of uh, the validation level, the performance data, like how confident are we in that? So provide that sort of validation with a link to the valuation. So say, okay, these are the studies that have used this in some similar respect or in a way that would be relevant. And then it would recommend types of filters, types of flow rates for that sampler, or in the case of sampler B, make sure you include the wall deposits. And that's really the goal, is for folks to be able to have that. And it helps, also maybe justify what you're doing and what you want to do in the future. Maybe it helps you present that to somebody else. Say, yeah, we want to do this type of sampling, and we've got validation from this sampler selection tool based on all this. That yeah, that's probably the right way to go. So again, that's coming. That is in process. This makes it look like it's still on paper, but we do have a little bit more developed on that. And then finally, I just wanted to mention our group again. We have a report on all our activities. So there is one report from, if you go to our website, from the first sort of 4 years, we kind of finally started putting a report together, and now we'll have annual reports, and you can see all the stuff we're doing. We're not trying to hide this, but some of it might not be publishable in scientific literature, but we want people to see what's going on in the world of sampler comparisons and what type of data is out there, what type of research is being done currently. And so finally, I just wanted to acknowledge all the people. So we've got the ISCG group. I've had a lot of kind of laboratory comparison group work with the UK. So Delphine Bard and her team in the UK, they have a bunch of sampler performance study setups. And then we have a lot of graduate students, and just to like really thank the NIOSH ERC mechanism for helping fund a lot of these students as well, who've been over the years, I think this is going back maybe 6 years, folks who have been helping in the lab, just trying to piece together some knowledge on sampler performance, some of it ongoing as well. And then we've got, like I said, that funding from NIOSH, the ISCG through some of those metal industries, but then also the Canadian WorkSafe BC group. They funded some individual projects, and so it's really nice to see ongoing interest in this, because like I said, we're a bunch of sampler nerds. We want to kind of get to the bottom of some of these and be able to tell you what's the best to use. So I think that is all I had. So thank you everybody I'll leave this one up for listening. Yeah, to me talk about samplers.
Well, thank you so much for your presentation and for your research. I'm sure I can envision this tool getting used pretty widely, and so it's great that you're putting it together. Thank you for that. At this time, we do have time for questions. So if you have a question, please enter it into the Q&A, and I'm happy to ask that um, for today. The first question that I have is, what do you see for the future of aerosol sampling in this area? What do you think is coming down the pike?
Yeah, so thanks. Yeah, I mean, like I said, we really want to get something standardized. I would love to see in the future, like not 100 options. But I mean, we're not going to only have one, right? If you're sampling, even if just keep mentioning silica and metals, and you're not necessarily going to have one sample, but knowing what you can, like if you ever look in like um the SKC catalog or whatever, and you have all these different sorbent tubes, right? You know what you have to sample, use a sorbent tube. If we can have something like that where it's like, okay, you're sampling silica, here's your sampler. If you're sampling metals, here's your sampler. I think that would be great. But even if we can have more you know, maybe more innovation in terms of sampler, like sampler pumps and sampler technology, where we have a lot more real-time data. How can we integrate that here, right? I'm talking about really traditional aerosol samplers. So the next step might also be standardizing those real-time samplers for occupational environments. Yeah. Oh, and actually I saw a request for the QR code, so I'm gonna go back.
Oh,
There
yes,
you go.
great.
Yeah, there you
Thank
go.
you. Awesome. And then it looks like someone was also asking for the commentary paper. So
Oh yeah, so that's still under review. So it when it comes, it will be published in the journal. So you can reach out to me again, and we can um, I can tell you how to get that. Yeah, that's
excellent. Thank you. Another comment, just that it would be really nice to see these results incorporated into the NIOSH SAM, the NIOSH Pocket Guide, OSHA Field
mhm.
Operations Manuals, and etc.
That's great. Yeah, we would love, especially I know OSHA doesn't regulate inhalable air, so I didn't say that at the front, but I know that's something that I would love to see. Just getting that more collaboration with NIOSH and OSHA on that stuff. So um, absolutely, if we can get hooked up with how NIOSH, even just the manual of analytical methods, I know they have some of this information, they have some stuff, but that would be great. I love that. Yeah.
Great. Another question, how far must the samplers be apart to avoid interference between samplers when you're doing co-located sampler tests?
Okay, great question. Yeah. So we actually did some calculations on this one time because the question kept coming up. But really the samplers are pulling their airflow is so low that they don't have as much of a reach as you think. So definitely putting them on one side of the shoulder and the other is fine. But even like a couple inches between them is going to be fine. Yeah, on one shoulder, it's definitely if you go back to your ventilation textbook and want to, you can do simple calculations of the reach of that. But yeah, that's a great question that we've had in the past. But it's surprisingly they don't interfere all that much when they're side by side.
Thank you. Is there a recommended method for sampling for liquid aerosols that contain regulated particles, such as spray paints that contain crystalline silica?
Oh, yeah, that's a great question too. And that is one thing that there is some good data on liquid aerosols and what samplers may or may not be good. So for the liquid aerosols in particular, the button sampler would not be recommended because if you know that one, it's got a lot of tiny holes. So anything that's like that that has very small holes can get the liquid aerosols can clog that. You get like surface tension build up on it. Um, so in general, liquid aerosols more would be better for the larger inlets. Um, I don't know specifically. What did you say about regulated like spray
They were
paints? Yeah.
specifically, yeah, talking about spray paints that contain crystalline silica.
Okay. Yeah. No, that's a really interesting one. Um, so if you're probably doing respirable samplers. So I would suggest in that case looking at there's some data on cyclones versus impactors in terms of that liquid aerosol. And so I think there is some data on that. And that is one of the factors we're including in the tool is the solid versus liquid aerosols. But yeah, I would look at impactors versus cyclones in terms of liquid aerosols to maybe get deeper into that question. Yeah.
Thank you so much. We do have time for more questions. I saw a couple folks had raised your hands. You are welcome to enter your questions. You can type it into the Q&A or into the chat, and I'm happy to ask your questions. Another question that I have is just thinking about all the different samplers that you've been looking at. Were there any kind of like big surprises that came up as you've been doing this research?
Well, one thing I mentioned was the Dor Oliver cyclone. I didn't know how well regulated it was. And that sampler's not really used around the world. Like our group is pretty international, and so I think there was surprise to all of them too that was um much more sort of meticulously monitored. Because we've seen you know, different manufacturing batches of things can actually look kind of different. So it might have added a slightly different, like with the IOM sampler, at some point they added an internal like um, lip inside to hold the foam, right? And so like these kinds of things are just made and put out there. And so yeah, I guess I was a bit surprised at how little regulation there is on what this is and what gets put out there. Um, yeah, and that's a great question.
I guess kind of continuing on that thread, you have that contrast between a sampler that is really well regulated, monitored, tested, versus others that are just kind of put out there. Do you see a place for kind of monitoring these things more closely, and having some regulatory guidance? Also in recognition that this is an international working group, is that something that there's examples from different places in the world that pay attention to different types of samplers?
Yeah, so I think that you hit on a couple things there. It's hard to potentially do something internationally as like everybody should use this one thing, right? If you look at European countries, especially with the inhalable type samplers, they all have their own. So they've all developed their own. So like in Germany, they have the GSP. In the UK, they use the IOM. In France, they have this CIP. So it's you know it. But I mean, given that that is the sampler they use, right? So that in a given country, there's a lot of internal usage and data for it. But if you what some of what we're doing is like comparing those those maybe those all those together, and some are better than others, but are they all like okay enough for like if there's one sampler for like the United States, right? I think that that could be potentially be something that would be um, useful, right? So the one of those common samplers is that closed face cassette that people use for sort of total dust type things. We could do that for other types of samplers, and I think that in some way it helps eliminate um, a lot of the uncertainty. If you go from one place to another, or even in like one company from like one team to another team, are they using the same stuff? And it would help with some of that uncertainty so that things were comparable. If you went to a mine, in Utah and then went down to Arizona, like, and they're collecting samples, could you compare them? Well, if they're using totally different instruments, it's hard to know, right, if that's comparable. So it's possible, but I'm not sure if there's impetus, there's motivation from regulators to do that. But I would like to see that.
Thank you so much. I've had a couple more questions come in. Is PPI better or the same row cyclone for respirable silica and dust?
Yeah, well, that is a great question because I think that that's one of the things we are, not just us, but people have been looking at because I think that PPI has a lot of advantages compared to a traditional cyclone. And and so I think at the moment, I wouldn't say one is better, but I would say at the moment it's looking like it's just as good. And in terms of usage, like ease of use, definitely. And also you can get it in different flow rates, which is nice. So for those lower exposure limits, you can use a higher flow rate on some of them. So I mean, I think the more data that's coming out, I think it will probably rise to be a little bit more of a go-to sampler. But I'm not sure there's enough data comparing them at the moment, specifically comparing them at the moment. So yeah, but I think that's definitely something to look out for.
Awesome, thank you. Another question, did you compare an inhalable sampler versus cyclone sampling for welding metal fumes and impact of using a cyclone on elemental separation during sampling?
Oh, right. Yeah. So I am trying to think of the data. We didn't do anything ourselves on welding. There is a bunch of literature on welding. And what I would probably suggest you look for, and I think some of it in our commentary and selection tool, like I know welding had quite a lot of information on it, but specifically comparing inhalable to cyclones, um, I don't know offhand. So what I would suggest maybe you look at is the dual fraction sampler that's like the inhalable that has a respirable inlet, a respirable foam in it. And that I think there is data comparing that with cyclones. Um, but for the elemental, I think you mentioned the elemental metals. So yes, I don't know specifically literature offhand, but I know there is some on that topic. So I would look up the dual fraction sampler for compared to the cyclone in that case. Yeah.
Thank you. And I know you mentioned too, you are interested in some practitioner feedback, especially around usability and practical field applications. If folks wanted to give you some of that feedback, where might they look or where might they begin?
Oh yeah. Well, I don't actually, did I not put my email on here? Well, it's you can just email me directly. Um, it's darrah.sleeth at hsc.utah.edu. You can contact the website's right there. You can contact us there on uh, through the ISCG group. Please feel free to contact us through there. Actually, I think all our contact information is on there. But yes, please, if you've got things you want to talk about, if you've got data that you're like, here, you can, want to share it, or if you've got experience you want to impart, yeah, that would be fantastic.
Thank you
Oh,
so
thank you.
much.
You put it in there. Okay.
Oh, yes, yes. I just put your email in the chat. It looks like we do have one more comment. Just a note that there is some international interest in collaborating on standardizing methods. Someone notes that several years ago they attended an IASH-hosted meeting on reviewing and standardizing sampling and analytical methods, and about
Mhm.
half of the attendees were international. So who knows?
Great.
Maybe some of the work you're doing could lead to some standardization efforts. That would be
Yeah.
great.
Yeah, that's great. Yeah. Yeah, I know there's the like analysis. I feel like the analysis side has um had a lot of push in that area. So people trying to standardize, ICP and, GCMS, that kind of application. And so, yeah, I'd love to see the sampling side of that sampling and analysis kind of join the conversation, like what you're talking about, the webinars or the workshops and stuff. So, yeah.
Awesome. Well, thank you so much for your time today. Thank you for your
Yeah.
very important work. We really appreciate you being here, and we appreciate everyone who joined us online for the presentation today. We wouldn't be able to continue doing this without all of your support and your attendance, so thank you all for being here. Be sure to check out our website for more information and to register for other upcoming webinars. We're coeh.berkeley.edu. And I'm going to put that in the chat as well. And as a reminder, you'll get an email with the link to the evaluation form. And we hope to see you all on another webinar again soon. Thank you so much, Dr. Sleeth.
Yeah. Thank you for having me. Appreciate it.
Take care, everyone.